Before, no one and many scientists didn't believe Wegener's theory of continental drift because he failed to explain or give a concrete evidence on how the plates move. Now, we'll discuss the seafloor spreading theory and how it helps to prove the theory of continental drift by Wegener. So many people in the past believed that ocean floor is flat like a desert. But in 1930s, where sounding gear called sonar or sound navigation ranging was developed, it leads to the discovery of the standing features of the ocean floor. Ang sonar is ang device na ginagamit or that uses sound waves to detect objects. Ang sonar device sends pulses of sound wave down through the water. When these pulses hit objects like fish, vegetation, or the bottom, they are reflected back to the surface. The sonar device measures how long it takes for the sound wave to travel down, hit an object, and then bounce back. It's the same echolocation system bats and dolphins use. This information enables the device to judge the depth of an object. It also measures the strength of the returning pulse. So the harder the object, the stronger return pulse. So, gamit itong sonar, malalaman kung ano-ano ang makikita sa ilalim ng karagatan and kung ano-ano or kung gaano ito kalalim. So these are the discoveries using sonar. First is ang ocean floor is not just flat. So nakita ng mga scientists na hindi lamang bastang flat or basta-basta na flat ang ocean floor or ang ilalim ng karagatan. And it has underwater volcano valleys, trenches, and mid-ocean ridges. Ito daw ay merong mga iba't ibang feature na makikita sa ilalim like Rift Valley, trench, mid-ocean ridge, and we see these at the middle at the Atlantic Ocean. One of the scientists who studied the mid-Atlantic Ocean ridge and used sonar during the World War II was Harry Hammond Hess, a professor of geology at Princeton University in USA. Harry and his team carefully examined maps of the mid-ocean ridge system. He has begun to think about the ocean floor in relation to the problem of continental drift theory that leads him to the idea of seafloor spreading. Seafloor spreading is a process where new oceanic crust is formed in mid-ocean ridges and slowly pushes the old crust toward the subduction zone. This is the process where new oceanic crust will form at the mid-ocean ridge and unti-unti daw tinutulak yung mga old crust papunta doon sa subduction zone. According to seafloor spreading theory, the hot, less dense material below the earth crust rises towards the mid-ocean ridge. Then these materials flow sideways, carrying the seafloor away the ridge and create a crack in the crust. Then the magma flows out of the crack, cools down, and becomes new seafloor. Over time, the new ocean crust will push the oceanic crust far from the ridge and subduct it. So this happens at the divergent boundary where plates move apart, and gaya ng napag-aralan natin before na mainit na material which is coming from, or the molten magma which is coming from the mantle, nag-move siya upward, so pushing old crust to the subduction zone. So ang katong molten material na nag-move sa taas, dahil nagdi-decrease or bumababa ang temperature, they will form or magsisimula na silang mag-solidify, and ito ay magiging new crust. So we have here the evidences of the seafloor spreading, mga ebidensya na ginamit kung saan nagpapakita na mayroong seafloor spreading. First is ang age ng rock, where rocks are younger at the mid-ocean ridge and older at the subduction zone. So they found out, or scientists found out, that youngest rock or katundang mga bata pa na mga rocks or bag-o nga na form, they are found near at the ridge, while ang katong mga daan na they are found far from the ridge. It's because diba pag-create atong bag-o, gina-push niya tong mga daan na. That is why old rocks are found far from the ridge. Younger yung mga bagong crust, at yung mga nasa malayo ay ang mga older crust. Sila yung nasa subduction zone na. So new crust is being created at the ridge daw. Diba, younger rocks are found near the mid-ocean ridge, and dahil dito, kung maalala nyo, habang ang molten material ay tumataas or umaangat, kinatulak to niya palayo ang katong older crust. That is why yung bagong molten material, kung mag-solidify na to siya, mauna to siya ang new crust na mabuo, and mao to siya mapunta sa itaas. And that is the reason why new crust is being created at the ridge. So old crust is pushed and destroyed at the subduction zone. So kapag napunta ang older crust sa subduction zone, hinihila ito pababa. From the term itself, subduct, so papunta siya sa pababa, so hinihila daw ito pababa, and dahil doon the slab pull, at kapag ito ay nagkaabot na doon sa layer ng mantle, which is mayroon siyang high temperature, ang mangyayari doon, older crust is magme-melt siya na yung magme-melt na yung mga rocks, and matutunaw na yung mga bato dahil sa high temperature na nandoon sa mantle or sa subduction zone. Kaya sinasabing in the subduction zone is may mangyayaring destruction or destruction at the subduction zone. So nagkakaroon tayo ng construction or formation of new crust sa mid-ocean ridge, while nagkakaroon din naman tayo ng destruction at or nadi-destroy naman itong mga old crust sa subduction zone. The formation of new crust daw at the mid-ocean ridge is not always as fast as the destruction of old crust at subduction zone. Sabay na mangyayari ang seafloor spreading at ang destruction. So ang formation of new crust sa mid-ocean ridge, dili siya permanente na fast, pareha, sa as fast as destruction at subduction zone. Meaning sabay lang daw sila na mag-undergo ng process ng formation at saka destruction. Sabay na mangyayari ang formation, ang process ng formation at destruction, pero hindi magkasing bilis. If seafloor is faster than subduction, the ocean gets wider. So kung paspas daw ang pag-create ng seafloor or ang formation of new crust kaysa subduction, ang mahitabo daw mas mo lapad ang ocean. Well, of course, if sige lang og buhat or panghatag or create og new crust, so mag-wide jud ang seafloor. But if mas mabilis naman yung destruction at the subduction zone kaysa sa seafloor spreading, magiging smaller daw yung ocean. So diba, pag paspas daw ang spreading, mas mo lapad ang ocean. So kabaliktaran na po siya pag mas paspas ang destroy or destruction sa subduction zone. So pag paspas, mahitabo mo gamay ang ocean. Example ani sa paggamay sa ocean is ang Pacific Ocean. Example for this is ang Pacific Ocean and the Atlantic Ocean. So sa Pacific Ocean, subduction is faster than seafloor spreading. That is why ang Pacific Ocean, it gets smaller. So meaning kung smaller siya, mas mabilis ang destruction sa subduction zone. Whereas ang sa Atlantic Ocean, mas mabilis ang formation ng new crust. That is why ang Atlantic Ocean it gets wider dahil mas mabilis ang formation ng new crust compared sa destruction of the older crust at the subduction zone. Another evidence that will prove or support the seafloor spreading is the magnetic reversal. It is also called a magnetic flip of the Earth. This means na nagbabago ang magnetic pole ng Earth. So ang Earth ang Earth daw ay may malaking magnet. It has the north magnetic pole and the south magnetic pole. Ang north magnetic pole daw ay makikita sa South Pole o doon sa Antarctica, at ang south magnetic pole naman ay makikita sa North Pole o doon sa bandang itaas. Today, this is the orientation of the magnetic poles on Earth. Pero pag sinabi nating reversal, magnetic North Pole becomes the magnetic South Pole of the Earth. Nagkabali sila, reversal. So pagkalipas, ibig sabihin daw, pagkalipas ng ilang milyong taon, nagbabago na naman ito, and magbabago na naman ito, kung saan ang North Magnetic Pole naman ay mapunta na po daw ito siya sa taas, and ang South Magnetic Pole is mapunta na po siya sa ilalim. This change in polarity of the magnet is called the magnetic reversal. So why is it na nagkakaroon ng magnetic pole? It is due to the change in the direction of the flow of materials in the outer core. So As the magma becomes the new crust, the rock solidify and follow the magnetic poles of the Earth at that time. So, sa panahon ng paglabas ng magma sa may mid-ocean ridge, yung magma ay magsusolidify and ang materials doon ay mag-a-align according sa magnetic pole ng Earth. And because of the change in magnetic pole, where north is seen as nasa baba, minsan naman ang south ay nasa taas, at paglipas ng panahon, nag-iiba na naman ito. This forms magnetic patterns on both sides of the mid-ocean ridge. And these patterns is a proof na mid-ocean ridges is moving and that seafloor spreading is really happening. How does seafloor spreading relate to the continental drift theory? Well, seafloor spreading indeed proved that continental drift theory is evident or is true na gumagalaw talaga yung mga plate boundaries. Seafloor spreading shows that the oceans are active sites of plate activity. It also shows that new crust is formed at mid-ocean ridge and old crust is destroyed at the subduction zone. And this also explains how plate move due to the convection current in the mantle. And because of it, seafloor spreading proved that continental drift theory is correct.